Lab 3 Measurement Part 1. Finding the surface area to mass ratio of a cube. The length of the cube. Use the ruler to measure the length of one edge of the cube to plus or minus 0.1 centimeters. Record the length of the cube in Lab 3, Question 1 on Canvas. The length of the cube is equal to blank centimeters. Record this Question 1 in Canvas, Lab 3. The surface area of the face of the cube is length times width. But since each edge of the cube is the same length, it is essentially length times length for the surface area of a cube. The surface area of one face of the cube, abbreviated SA, is length in centimeters times length in centimeters. The unit of the surface area of one face of the cube is centimeters squared. Record the surface area of one face of the cube in Lab 3, Part 1, Question 2. A cube has 6 faces: top, bottom, left side, right side, back, and front. Since a cube has 6 sides, the total surface area of the cube will be 6 times the surface area of each face of the cube. The unit for the total surface area of the cube is centimeters squared. Record the total surface area of the cube, TSA of the cube, in Lab 3, Part 1, Question 3. We are going to calculate the surface area to mass ratio of the cube. The surface area to mass ratio of the cube is the total surface area of the cube divided by the mass of the cube. Later in this lab, we will calculate the surface area to mass ratio of the bar. Why is the surface area to mass ratio important for cells? The reason the surface area to mass ratio is important is the surface area has a great deal of impact on cells. For example, when scientists are trying to develop new drugs to combat a new disease like COVID, the scientists would want the drug to have a surface area that is appropriate to attach, in this case, to the active sites on the virus. Surface area is also important for drugs to combat bacteria and fungi, as well as viruses. For example, if we look at the COVID virus, we see that the COVID virus has a spike protein that attaches to the ACE2 receptors. The spike protein is toxic and can induce inflammation. A team of researchers trying to develop a new drug to combat the COVID virus would look for a chemical compound, a new drug, which would attach in some manner to the spike protein.